This is the Geometry 2025 Spring Practice Final. It is going to be multiple choice for the final as well. Here we go. In the first problem, I'm noticing I have side lengths of a right triangle. That means I'm invoking Pythagorean theorem, a squared plus b squared is equal to c squared. I use my side lengths x and 5, and that's going to be set equal to the hypotenuse. Just as a reminder, the hypotenuse is always opposite of the 90-degree angle, therefore it's going to be 13 squared over here. You might have this one memorized as well. I have you memorize your 3 basic Pythagorean triples, which I'll talk about right now, and then I'll work myself through the rest of this problem. 3 things that you should have memorized for your test. You should have a 3, 4, 5 triangle. Meaning if I have a triangle with lengths 3 and 4, we always know that the hypotenuse is going to be 5. If I double each of those, I get 6, 8, 10, which is the next most common Pythagorean triple, and the next one, which this problem is a 5, 12, 13. As soon as I saw the 5 and the 13, I knew that I had a 5 and 13, meaning the remaining length should have been 12, and I can immediately get the 12 just from memorization. Those are called Pythagorean triples. There's a formula that generates those, but for now, let's go ahead and run through how to solve this one if you're just using Pythagorean theorem. From here, you would square each of these and you'd say x squared plus 25 is equal to 169. Subtract the 25 on both sides, subtract the 25, subtract the 25, and that would give you x squared is equal to 144. From there, you would undo the square by square rooting both sides, square root, and that would give you an x is equal to plus or minus 12, but it doesn't make sense for you to have a negative length, so I'm just going to say that the answer is 12, which we already knew from before. All right, number 2. Again, now we have to use Pythagorean theorem, and this is not a special triangle that's going to be memorized. It's not a Pythagorean triple. So let's use Pythagorean theorem again. We have a squared plus b squared is equal to c squared. Therefore, we have 5 squared plus x squared is equal to 15 squared. I've said this before as well, but it doesn't matter the order of your x squared versus your 5 squared. I could have done x squared first plus 5 squared second, and that still would have been fine. Adding the order doesn't matter. 1 plus 4 is the same as 4 plus 1. So square each of these, you get 25 plus x squared is equal to 225. From there, we will subtract 25 on both sides. When we subtract 25 on both sides, we get x squared is equal to 200. From there, we undo the square by taking the square root, taking the square root of both sides. It does typically have a plus or minus, but it doesn't make sense to have a negative length when we're talking about the side length of a triangle, which means x is just going to be the square root of 200. I'm noticing the square root of 200 is not listed, and that's because we need to have simplest radical form. So to simplify our radical, we'll take the square root of 200, and then we'll make a factor tree where each of the factors are perfect squares. I happen to know that 100 is a factor of 200, and 100 is also a perfect square, because when I take the square root of 100, it turns into a 10. But what is the other perfect square, or what is the other square root that I can multiply to get to 200? 100 times 2 is 200, therefore this is going to be a 2. Our final answer is going to be a 10 with the square root of 2. A 10 with the square root of 2 is going to be option D. In number 3, we have Pythagorean theorem yet again. This is going to be 10 squared plus x squared is equal to 14 squared. Square them, we get 100 plus x squared is equal to 196. Then we will subtract the 100 on both sides. Subtracting the 100 gives us x squared is equal to 96, and then we will undo the square by square rooting both sides, leaving x is equal to the square root of 96. Notice that the square root of 96 is nowhere down here because it's not simplest radical form. We will do a factor tree on the square root of 96, looking for perfect squares. As a general strategy for doing these, I typically look for the smallest squares first. Unless I see some sort of pattern. For example, in the square root of 96, I'm noticing that 100 would be nice, but it's too big. So then I'm going to start from smaller squares. Your small squares that you should always be checking, you should be checking 2 squared, you should be checking 3 squared, and 4 squared. Those are usually the most common ones, but sometimes 5 squared and 6 squared do come up as perfect factors, so just be wary of these. The first one that I'm going to check is 4, and I'm noticing that this one does go into 4. The way that I know that is this one is really close to 100, which is divisible by 4 because there's 4 quarters in a dollar. If you just subtract 4 again, it's still divisible by 100, which means if I'll show you what's going on in my head. I'm really thinking, what is 96 divided by 4? I'm thinking, well, this is the same thing as 100 minus 4 divided by 4, which is the same thing as 100 over 4 minus 4 over 4, which is 25 minus 1, which is 24. 24 is one of the factors, and I know that the other factor is 4. Why did I decide to choose 4? Because that was one of my first things on my list of perfect squares that should be looked for perfect factors in my factor tree. The next thing I'm looking for is, 24 has other perfect squares that can come out of it. I know that 4 is a factor of 24, which means 6 is the other thing that's going to pop out. 6 times 4 is 24, and the square root of 6 only has factors of 2 and 3, neither of which are in my list of perfect squares. Therefore, I'm stopping there, and I'm going to turn the square root of 4 into a 2, the square root of 4 into a 2. I'm going to multiply all together. 2 times 2 times root 6 is 4 root 6. My correct answer is option D. Then I move on to number 4. With this one, we're checking this against Pythagorean theorem. So just as a way to remember this, if I'm looking at a squared plus b squared and c squared, one of three things will happen. You'll either have an equal to sign, you'll have a less than sign, or you'll have a greater than sign. If this side is equal to, then this one is known as a right triangle. If this left side is bigger, that means that these legs are way too big. So let me sketch you a triangle where the legs are way too big, a leg that's way too big, a leg that's way too big, and then this line over here, this angle right here is obtuse. So this is obtuse. And maybe I'll write it like this because it will help us remember it. Obtuse. Whenever the legs win, it's obtuse. But what happens if the hypotenuse is really, I think that's wrong, isn't it? Hold on, let me double check my work. So if these two legs are really, really big, doesn't it make this one big as well? I find it easier to really think about the hypotenuse here. Let me redo my logic. I want to purely pay attention to the hypotenuse to see what's happening with you. So let me draw something that has a crazy, crazy small hypotenuse. So let's pretend that my right angle is going to always be in the bottom right. If I do my right triangle that looks like this, all right, so this used to be the 90-degree angle, which is now much, much smaller. Now this one is super, super tiny. My hypotenuse is super tiny. So if the hypotenuse is tiny, then the alligator chomps on the bigger one. And that is going to be definitely an acute triangle. So it's acute. So I had it backwards. And then the other way, like if I have this right triangle, but I make this hypotenuse crazy, crazy big. So watch this. I can make it really, really huge. And then these legs are just barely able to span the direction because the hypotenuse is so large. That's going to be obtuse. So that's going to be, I'll write it up here, obtuse. Always compare the hypotenuse. If the hypotenuse is crazy big, the only way to hit that is to get an obtuse triangle. So what's going on here? We're going to check the left side versus the right side. Plugging these in. Oh, by the way, the largest side is the only one that can be a potential hypotenuse. So no, don't accidentally put that for a leg. I'm going to write down 9 squared plus 12 squared and then 14 squared. I'm going to compare these two sides, right? I can guess I'll have a line right here. It's going to be 81 plus 144 and 196. Adding these together is going to be 205. No, 225, isn't it? 225. And then over here, I still have 196. All right, who won? Well, 196. The hypotenuse lost, which means the hypotenuse is really tiny. Hypotenuse tiny means it's acute. Correct answer here should be A. In number 5, you're doing the same thing. I'm comparing all of these. And in this one, you don't know, is the square root of 170 the hypotenuse or is 16 the hypotenuse? And the cool thing here is you just square them all and then plug them in. You don't have to do it first. So if I square them all and write it next to it, 256 is going to be squared, 81 is going to be squared, and 170 is going to be squared. So I just squared all of these. When you square a square root, these two cancel each other out, leaving behind the 170. Hopefully you have 16 squared memorized. And which of these three numbers after being squared are the largest? 256 is the largest, so that's one that's going to go on the right, 256. And then these other two are going to be added, 170 and 81. Adding these together is going to be 251. So which one is bigger, 251 or 256? Oh, the hypotenuse one. If the hypotenuse wins, then we have an obtuse angle. So let's go ahead and say option A. And in number 6, let's go ahead and square each of these. 2 squared is 4. 10 squared is 100. This one squared is going to be, you'll have to be careful, right? Because when I square this, the square will both go to the 2 and to the root 29. 2 squared is 4, so I'll say this one's going to be equal to 4 times, because this one is a times in between. I'm just copying that symbol over here. The square root squared is going to be canceling each other out and leaving behind the 29, so it's 4 times 29. And I don't know how to multiply by 4 very quickly, but I can double and double. A double double is the same thing as times 4, so 29 doubled is really close to 30 doubled, which is 60, but it's a little bit less than that, so it's going to be 58. So I doubled this to get 58. I'll double that again and get 116. It's going to be equal to 116. And then I can say, okay, yeah, 116 is obviously the largest number, so I'll put that one on the right-hand side, 116, and then I'll add the other two, 104. Well, that's going to be 104. So which one is bigger, 116 or the 104? 116 is bigger, which was the hypotenuse. Whenever the hypotenuse is bigger, that means that I have a hypotenuse being really big like that, and the correct answer here is going to be obtuse. The correct answer should be A. And it feels a little bit wrong because usually I try to make an acute, an obtuse, and a right angle, but whatever, that's the answers I got. If I make a mistake, please let me know in the comments or tell me in class and get some extra credit. All right, number 7, trying to find the area of each of these. These are going to be done with a calculator, so let me go ahead and get my calculator ready to go. I'm going to do a scientific calculator off to the side. Let's go ahead and clear that screen, so clear all. All right, let's see. So we're just finding the area of all of these triangles until we hit to problem number 10. So the next three, finding the area. Just remember that area is base times height divided by 2, because it's basically a rectangle. Rectangle is base times height, and then triangle is always half of rectangle. All right, so we need to find this length to multiply base times height. I don't have this length, so let me go ahead and call this length x. So I'm going to say 7 squared is it the hypotenuse. That will be equal to 6 squared plus x squared, and let's move that over here a little bit. This can be 36 plus x squared is equal to 49. Subtract the 36. It's going to be minus 36 minus 36. X squared, therefore, will be equal to a 13. And then if I square root and square root, then x is going to be equal to the square root of 13. All right, so I'm going to say this now I can say is the square root of 13 down, the square root of 13 down here. I'm going to multiply root 13 times 6 and then divide it by 2. So I'll say now the area is equal to the square root of 13 times 6 and then divide by 2. And that's going to be, let's see, the square root of 13 and then times 6 divided by 2. It's going to be 10.8. Correct answer is A. All right, next one. I need base times height divided by 2. I don't have the entire base. I'm just missing that one. Let's go ahead and label that one as x for now. This was kind of interesting because that one's 6 and that one's 6, and they also have this same shared side length. I'm assuming here that this angle is perfectly cut inside. I have side, angle, side, and therefore these are congruent triangles. Therefore, if this is 4.6, this one is also 4.6. Use those shortcuts whenever you see them, guys. It has to be 4.6. Therefore, this entire base down here is, I'll say that the base here is 4.6 plus 4.6, which is equal to 9.2. Therefore, the area of a triangle is base 9.2 times height. Okay, we don't know the height, so I don't know that. I'm going to go ahead and call that y, and then divide by 2. So I'll leave it as a y for now, and then I'm going to go ahead and substitute that out and erase it later. So what is y? Well, it's going to be y squared plus 4.6 squared is going to be equal to my 6 squared. So I need to know what is 4.6 squared, and that's going to be 21.16 with my y squared. And it usually says in the instructions, I don't like doing this actually in mathematics. I really want to write my own curriculum. Round to the nearest tenth right in the middle of your process. So I'm going to turn this into a 21.2. This makes me feel icky. I shouldn't be doing this in real life. And that's going to be equal to a 36. Let's subtract 21.2 from both sides, subtract 21.2 from both sides, and that will leave me behind with a y squared is equal to, what is that going to be, 14.8. And then from there, we square root, and y is going to be equal to the square root of 14.8. Okay, so from there, I'm going to just write in here and say this is now a 14.8 being square rooted, and I'm going to type in 9.2 times the square root of 14.8, and then all of that divided by 2, and I get 17.69, which rounds up to 17.7, or 17.7. Oh, that's weird. We were off by a little bit, but I think it should be 17.9 for number 8. Don't know where I got off for my decimals. Maybe here, I think this is what maybe happened. If I take the square root of 14.8, that's 3.8. So let's call that one 3.8 instead. So I'll say all of you are going to turn into a 3.8. Let's see what happens if I do 3.8 times 9.2, then divide by 2, 17.5. Wow, that's crazy how much rounding really makes your answers off. 9.2 is yeah, I don't know where they're getting 17.9 exactly from. It really depends on where you're running in your steps. All right, and then number 9 we haven't done yet. We need base, we need height. We're missing 2 of these things. I'm going to call this one x, I'll call this one y, and we're going to have to squeeze this in here. So write small, Mr. Sindel. I'm noticing I can't find x first because I have 2 variables with a hypotenuse, but I can't find y first because I have these 2 numbers with a non-number. So I can say that y squared plus 8 squared is equal to a 17 squared, and that's going to be y squared plus 64 is equal to 289. I hope I have my 17 squared correct. Okay. And then I'm going to subtract 64. I'm going to start not writing these steps because I know that you guys know that whenever you have a variable, they always say, get away from me. Therefore, the 64 is going to go on the other side. And you're going to say y squared is going to be equal to 289 minus your 64, which is 225. Taking the square root of that, y is going to be equal to 15, which is kind of nice. It came out so nice. So this is going to be a 15. And now I can find the x. So I can say that to find my x is going to be x squared. I'll do a little wavy line. X squared plus 15 squared is equal to 20 squared, which is going to be x squared plus 225 plus 400. Subtracting 225 on both sides yields x squared is equal to, this should have been equal to sign right there, not a plus, is equal to 175. Take the square root of that, and x will be equal to the square root of 175, which is about 4.1. All right, so that means that the entire base down here is going to be 4.1 plus 8, which is 12.1. So I'm just going to say this entire length down here is 12.1. And then my area is going to be base, 12.1, times height, which is 15. That's a point right there, all divided by 2. So I'm going to say 12.1 times 15, and then all of that divided by 2. And I get 90.75, which is nowhere in the ballpark of correct because all my answers are over 100. So I have done something very wrong. I mean, just eyeballing this thing, 12.5 does make sense. Where else did I make a mistake? I'm looking, like 15 makes sense because it's a little bit less than 17. Base times height, 12.1 times 15, and then divide by 2. Where did we make a mistake? Oh, wait a second. When I took the square root of 175, the answer should have been over 10, and I got 4. Oh, I didn't type it on the calculator. I typed in 17 without the 5. There we go, 13.2. Okay, let me come down here and change you to a 13.2. That was really silly. 13.2. So if that's a 13.2, that makes much more sense. That makes sense. Okay, so 13.2, if I add that with 8, I get 21.2. So I'll change this to a 21.2. 21.2. So let's say 21.2, please. Okay, I'll do it like that. 21.2 times that is going to be 159 on the dot. All right, and that's what we got as well. All right, number 10. We're leaving radicals in simple form. Oh, okay, so these are all special types of triangles. I'm seeing 45, 45, 90. I'm seeing a 90, 60, 30, or 30, 60, 90. All of these are special triangles, so just to review your rules, whenever you're trying to get from the leg to a hypotenuse for a 45, 45, 90, we multiply by root 2. If you ever want to go backwards, if you want to get from something long to something short, you do division for these triangles. And then over here, whenever you have a short leg and you're trying to get to the hypotenuse, we'll multiply by 2. From the short leg to the longest leg is multiplied by the square root of 3. Those are the only 3 things that you need to know. And from there, we can kind of do everything. Okay, let's see. In number 10, we're trying to get from 3 to over here, which means x should be 3 times the root 2. X should be 3 root 2. Okay, so that eliminates a and c. So 3 root 2, 3 root 2. And then y and 3, these are the same lengths. They have to be the same lengths for 45, 45, 90 because the derivation comes from a square where all of these lengths are the same. Therefore, y has to be just 3. This one is not saying 3. That one is saying 3, so the correct answer is D. What about number 11? Number 11, in order to move over here, we're just multiplying by 2. 2 times 2 is 4, so I'll put a 4 up there. If a is 4, that's going to be between c and d, so it's just c and d. And moving over here, 2 times root 3 is 2 root 3. 2 root 3 is going to be option C. What about number 12? Well, I know normally to get from here to here, I would be multiplying by the square root of 3, but I'm going the opposite direction. I'm getting to something smaller, so I'm going to be dividing by the square root of 3. When I divide by the square root of 3, weird things happen. 5 divided by the square root of 3. You can't have square root of 3 in the denominator because someone said so, not me, and therefore we're going to get rid of it by multiplying the square root of 3, multiplying by the square root of 3. This is going to be 5 root 3 on the top, and then on the bottom I'm going to have the square root of 9, and the square root of 9 is just 3. So 5 root 3 over 3 is going to be what we want for y. Y is 5 root 3 over 3, so done. That's the right answer. Those are all incorrect. And then in order to get from here to here, you just double it, which is interesting because that's, oh, y should be 5 root 3 over 3. This is saying y is 10. Wow, I'm glad I reread that one. The value of y is that value that we got. And then to get from here to here, to get from here to here, we double it. Doubling the 5 turns it into a 10, and everything else stays the same. Nice. All right, number 13. Ooh, so this is one of those problems where you have to kind of go all the way around and do the property multiple times. So we're trying to get to this length of x, and we only have this hypotenuse. So we're going to go from the hypotenuse around to the short leg, around to this long leg. This long leg is actually the short leg of this giant triangle, and then I'm going to go around this way next. All right, so here we go. First step is to go from here to here. I'm going to divide by 2, and this is going to be 4 square root of 3. I'll write out my work. Divide by not squared, just divide by 2. And then to move from here to here, you're going to multiply by the square root of 3. So that's going to be 4 root 3 times the square root of 3. Remember, when we multiply, the roots and roots stick together. So root 3 times root 3 is going to be the square root of 9, and the square root of 9 is just 3. So it's going to be 4 times root 9, which is going to be equal to 4 times 3, which is just 12. So this length right here is 12. And now that we have this short leg of this giant triangle, I'm going to move from that short leg to the long leg. The way that we do that is to go from here to here, and we're going to multiply by the square root of 3 again. So 12 times root 3 is 12 root 3. The correct answer here is, A. Moving on to number 14. In number 14, we have some more of these problems. Again, I have this hypotenuse. I'm going to move to this leg, and then I'll move to this leg. All right, so to move from here to here, I'm going to divide by the square root of 2. So 7 divided by the square root of 2. I can't divide by the square root, so I'm going to get rid of the square root by multiplying by the square root of 2. Square root of 2, this is going to be 7 square root of 2 on the top, the square root of 4 on the bottom. The square root of 4 is going to turn into just 2. This is 7 root 2 over 2. Okay, so 7 root 2 over 2 is helpful. 7 root 2 over 2 is this value right here. And now I'm going to move from here to here. In order to move from the hypotenuse of 45 and 90 to a leg, just like we did over here, we're going to divide by the square root of 2. So I'm going to have this number, 7 square root of 2 over 2. And I'm going to divide it by the square root of 2. The way that we do that is we just put the square root of 2 on the denominator. That's what it means to divide. So it's really going to be 7 root 2 over the square root of 2 with the 2 in it. I just move the square root of 2 into the denominator down here. And notice that now I have square root of 2 and square root of 2 that can cross cancel, and it can cross, and the answer is just going to be the 7 over 2, which is going to be option D. All right, number 15. Kind of the same thing. We're going to go long leg to the short leg to the hypotenuse to the next hypotenuse. That's our entire step. So moving from here to here, long leg to short leg is to divide by the square root of 3. So 7 square root of 3 divided by the square root of 3. Notice that the square root of 3's are going to cross cancel, and we're going to be left with just 7. So this is going to be a length of 7. And now to move from 7 to the hypotenuse, we're going to multiply by 2. 7 times 2 is just 14. Now that we have 14, we're going to move to the hypotenuse. To move from the short leg to the hypotenuse, just like we did over here, we're going to multiply by 2. So 14 over here times 2 is going to be 28. The correct answer is going to be B, 28. Number 16, sine. So this one is going to be helpful to remember. SOHCAHTOA. For SOHCAHTOA, sine is going to be this S, which means it's going to be the opposite of the hypotenuse. So X is our angle of reference. Opposite is going to be 24 over the hypotenuse, which is 26. So the answer is going to be 24 over 26. But I'm noticing that none of those are listed. That's because this fraction is not simplified. So divided by 2 is going to be 12 over 13, and we get option B. For number 17, tangent from SOHCAHTOA is going to be the opposite over the adjacent for that letter T. Z is my angle of reference, so opposite is going to be 16, and then adjacent is going to be 30, so it's going to be 16 over 30, 16 over 30. That's going to be reduced. Divided by 2 is going to be 8 over 15. 8 over 15 is going to be option C. And number 18, we'll need a calculator, so let's go ahead and open it up right now. We need to set up a trigonometric angle or function. So I'm noticing that I'm using the opposite. I'm using the hypotenuse. Opposite and hypotenuse are the O and the H. O and H are used by sine. So I'm going to say sine of my angle, I'm just going to call it theta for now, is going to be equal to my 50 over my 54. 50 over 54. I want to get this angle by itself. That's what it's asking for after all. It's finding the measure of the angle. So I need this angle by itself. I need to undo sine. The way that we undo sine is we take the arc sine. So I say sine to the -1. That's the arc sine. And I do sine to the -1 of this side as well. And then these arc sines will cancel each other out, leaving behind theta. That's going to be arc sine of 50 over 54. Let's come over here to my function and say arc sine of 50 divided by 54, and that's going to be 67.8. 67.8 is closest to 68. Correct answer is D. What about number 19? 19, I'm noticing that I'm using the opposite and I'm using the adjacent. That's going to be the function tangent, because tangent is TOA, opposite over adjacent. So therefore, tangent of my angle is going to be equal to 39 over 38. And then I need to make some room for this one in order to take the arctangent. Arctangent of the left side, arctangent of the right side. Arctangents will cancel each other out, leaving behind what I need to enter in my calculator, which is going to be arctangent of 39 over 38. That's going to be 45.7. 45.7 is really close to 46. Correct answer is going to be A. I'll write it out. 45.7 is what I got. All right, moving on to number 20. Find the missing side, round the nearest tenth. Again, you're using trigonometry. I'm noticing that this is my angle of reference. I'm using the opposite, and I'm using the adjacent, which is going to be the tangent function again. When I write out my tangent of my angle, 62, that'll be equal to my opposite x over my adjacent of 11. to get my x by itself, I need to undo divide by 11. So I'm going to multiply both sides by 11, multiply by 11, multiply by 11, and my final answer, x, will just be 11 tangent of 62. 11 tangent of 62 is 20.68, which is about 20.7. 20.7 is going to be option A. In number 21, we have kind of the same setup. I am not using the opposite this time. I'm using the adjacent and I'm using the hypotenuse. Adjacent and hypotenuse is a cosine. Cosine of my angle 64 will be equaling 10 over my x. To get the x isolated, you can use this cool little trick where I'm thinking of this thing as divided by 1. When I think of it as divided by 1, these diagonals can switch. If I switch those diagonals, I'm now left with x is equal to 10 over cosine of 64, and I can just enter this in my calculator and I'm done. So 10 divided by cosine of 64 is 22.8. 22.8 is option A. Very nice. All right, moving on to number 22. Okay, so this is using trigonometry and we're trying to find area. Or no, we're just trying to find the side labeled x. Okay, these are finding area down here. So finding the side labeled x, I'm noticing that I don't have very much information on this triangle right here. I only have one piece of information, two pieces of information over here. So I can use these two pieces of information to find something else about this triangle on the right. I need two numbers in order to find that number. So let's go ahead and say my first step is going to be finding x. Well, I can't call that x. I'll call that y. X has already been used. So let's find y using this triangle on the right. So I'm noticing I have an opposite and I have an adjacent. That's going to be a tangent function. So I'm going to say that tangent of my angle 30 is going to be equal my opposite 49 over my adjacent, which is y. Again, I'm going to switch my diagonals. These two diagonals are going to switch. So y is going to be equal to 49 over 30, or tangent of 30 really. So 49 divided by tangent of 30. Tangent of 30 is going to be 84 we'll just call it 9, 84.9. So I'm right, 84.9 is up here, and now I can use new trigonometry on this triangle on the right hand side. So notice that I have an opposite and I have a hypotenuse. That's going to be sine for the so sound of SOHCAHTOA. So I'm going to say that sine of 39 will equal my opposite, which we now know is 84.9 divided by hypotenuse is x. And again, let's do that trick where we switch these diagonals. Switching the diagonals gives us x is going to be equal to 84.9 divided by sine of 39. And because I have that number entered in the calculator already, I can just type in answer divided by sine of 39. Sine of 39. And I get 134.8 or 134.9. 134.9 is going to be option A. In number 23, we need to find the area. Remember, to find area, we need base and we need height. I'm missing the base and I'm missing the height. Therefore, we need to find those things. So the first thing I'm noticing is that this triangle on the left only has one piece of information. Therefore, there's nothing we can do. We need two pieces of information to solve these. I'm noticing this triangle on the right does have two pieces of information, a 37 and a 40. Let's go ahead and it would be meaningless to find this hypotenuse, so don't find that. We do want to find this length over here. So that's in terms of the 40-degree angle for my angle of reference is going to be this adjacent and that opposite. Angles that relate opposite and adjacent are tangent. So I'll say tangent 40 is equal to the opposite 37 over adjacent, which in this case I'm going to call that x. We'll call this one x for now. In order to solve for x, let's switch the diagonals as that trick, and I'm going to say x is going to be equal to 37 over tangent of 40. Let's type that in. We're going to type in 37 divided by tangent of 40. We're going to get 44.1-ish. So I'm going to label that 44.1. Notice that we have the height now of our triangle. We're just missing the other base to find the entire base of the triangle. So to find this length down here, I'm noticing I have an angle, I have a side length, I need the other side length. That's going to be a tangent function again. So I'm going to do this one in blue. I'll say that tangent of my angle that we do know, 24, is going to be equal to the opposite, which we don't know. I'll call that length down here y, over my adjacent, which I do know, which is 44.1. And then I'm going to multiply both sides by 44.1 to get rid of it. I'll say times 44.1 times 44.1. And then those are going to cross cancel. Therefore, y is going to be equal to 44.1, which is the thing that we just got, answer. And then I'm going to multiply that by, not divide by, but multiply that by tangent of 24. Tangent of 24. And that's going to be 19.6. So I'll label this as 19.6. Excellent. So now I need to find the entire base times the entire height and then divide by 2 for my triangle. So I'll come down here and say that the area of my triangle is going to be equal to the base, which is 19.6 plus 37. That's the entire base times my height, which is 44.1. And then I'm going to divide that by 2. So let's just type that in. I'll do in parentheses. Let me set up my fraction first. So it's going to be let's get rid of all this. So I'm going to set up my fraction. I'm going to say the top of this is going to be in parentheses 19.6 plus 0.6 plus 37, and then that is going to be multiplied by 44.1. When I multiply that, it's not working because the denominator is not there. The denominator should be 2, and we get 2,496. Oh no, that's not an answer. So we have made a mistake. I'm just eyeballing everything. Does everything look okay? Everything does look okay. I typed in 1 instead of 2. Divide by 2. Oh, 1248. 1248 is going to be option B. Let's try number 24. Number 24, again, we need area of a triangle, which means we need a height, we need a base. We don't have any of those three measurements. So let me give our goals. We want an X, we want a Y, and we want a Z or Z. Once we find these, then we can plug them in and find the area of the triangle. All right, so I'm looking first for two pieces of information. I'm noticing that this triangle on the right only has one piece of information, so we can't start on that one. Let's start on the left-hand side. So I have 39. Let's go ahead and try to find X first. I could have tried to find Y first. Either way, whatever floats your boat or sinks your sub. So finding X first is going to relate this angle of reference with the adjacent and the hypotenuse. That's going to be cosine. Cosine of 62 will equal my adjacent over my hypotenuse, 39. To get rid of the 39, I'll multiply by 39 on this side, multiply the 39 on this side. It'll cancel out the 39s, and I can just type this in. I get 39 times cosine of 62, cosine of 62, and that's going to be X will be equal to 18.3, 18.3. Let's label that as 18.3 up here. And then I can find either Y or Z next. Let's go ahead and find Y next. So the relationship with Y and 62 is going to be the opposite and hypotenuse, which is a sine. So I'm going to say sine of 62 is going to be the opposite, which is Y, over the hypotenuse, which is 39. Again, we get rid of 39 the same way by multiplying by 39, multiply by 39. 39s are gone. And I'm going to type in what is 39 sine of 62. And that's going to be Y is equal to 34.4, and I'll label that as 34.4 on my diagram as well. And then finally, I want to find this Z. So the relationship there is going to be angle, and then I have opposite and I have adjacent. Opposite and adjacent is going to be my tangent. Wow, I used one of each of these functions. So I'm going to say tangent of my angle 55 is going to be equal to my opposite, which is going to be 18.3 divided by my adjacent, which I don't know. I'm going to call that Z. And again, to solve for Z, Z is trapped in the bottom. Let's go ahead and use that triangle or the trick where you can switch the diagonals. So that's going to be Z is going to be equal to 18.3 divided by tangent of 55. And I can just type that in. I have 18.3 divided by tangent of 55, and that's going to be equal to 12.8. So I can label it as 12.8 down here, and now I can just go ahead and find the area of the triangle, because the area of the triangle is going to be the base. So my base is going to be, area of the triangle is going to be equal to the base, which is going to be two things added together. I have a 34.4, and I have a 12.8, and then I'm going to add that together, and then I'll multiply by the height. Height is 18.3. Am I not able to write there? 18.3. Then I'll divide that all by 2. So let's write that all down. In my calculator, I'm going to have a fraction. Let's go ahead and start up my parentheses, and it's going to be 34.4 plus, ooh, that's a minus, so plus 12.8, and that's going to be multiplied by 18.3, all divided by 2. I get 431.8 or 431.9. 431.9 is going to be option D. And my daughter Lily is awake, which means I'm going to come back and record the second half of the video another time. Thanks for watching.